Okay, so in today's video we're going to have a look at Pythagoras' theorem. Now we're not really going to look at the ins and outs of why Pythagoras' theorem works and how it's sort of created. We're more just going to practice the actual use of Pythagoras' theorem here and just looking at how we would apply it to a certain question. So grab a piece of paper, grab a pen, make some notes. We're going to kickstart with this question. Now hopefully we are aware that Pythagoras' theorem is a squared plus b squared and that equals c squared. Now in terms of what the letters mean, A and B just represent the two shorter sides and they can be written either way. So given this question that we've got here, we've got the 10 and the 20, I could say that the 10 is A and the B is 20. Or I could do it the other way around, it doesn't matter, but A and B are the shorter sides and C represents the longest side, which is called the hypotenuse. Now when we're looking at Pythagoras' theorem, there's two different scenarios that we can have. We can have one where we're looking for the longest length, the hypotenuse, or we could be looking for one of the shorter lengths. Now in this question here, we're trying to find the longest length, and you can find which one's the longest length by sticking an arrow out of the right angle. The longest length is always opposite the right angle. So that's just a way of identifying the hypotenuse if you can't see it, because I do appreciate that some people can't just see which one's the longest length, but there's a little trick for you to actually find it. Now when we're looking at this then, we've got 10 and 20 as our shorter sides, so all we have to do is plug them into Pythagoras' theorem, into the formula, and then we'll actually just be able to work out the hypotenuse from there. All you have to remember is the way that you write it in, and just be very careful with that. So if we do a squared, that's 10 squared, and if we do b squared, that's 20 squared. Now in this scenario we are looking for the longest length, so when you're looking for the longest length you add these two together. So we have 10 squared plus 20 squared, so you can just type that straight into your calculator, 10 squared plus 20 squared, and that equals 500. There you go, and that equals 500. Now obviously for Pythagoras' theorem that number at the end there is c squared, and we don't want to know c squared, we want to know what c is, the actual length of the side, which we're being asked for in this question. So to reverse squaring something, so to reverse c squared, you do the square root. So all we have to do to finish it off is do the square root of 500, and it's nice on a calculator question because you can just press square root, answer, and press equals, and make sure you write down the decimal version of that. And the decimal version of that comes out as 22.36. Let's have a look, 22.36, and after that is a 0.67. Now you should write down all the decimals really, but I can see it wants the answer here to 3 significant figures, which it says in the question. So I'm just going to leave it as that, because at the moment I've got it to 4 significant figures there, so it's enough there for me to actually be able to round this in a sec. Now just as a little side note, now the majority of the questions we're going to focus on in this video are going to be calculator based, but it doesn't always have to be calculator, okay? That number there, that 500 that we've got, could come out as a square number. So knowing your square numbers in this question here, obviously for a non-calculator question, is really important, and just being able to write those square numbers down. In fact, you know, all the way up to 15 squared, something like that would be a good amount of square numbers to make sure that you know. So finishing this off then, it says to round it to 3 significant figures. Now the third significant figure here is the 3, the 2 being the first one, the second 2 being the second, and the 3 there being the third significant figure. So our final answer here is going to be 22 point, and the 3 rounds up to a 4, as it is a 6 there in the 4th significant figure place, and this is centimetres, so obviously just making sure you write units down there. So 22.4 is our final answer, and there is our first example of Pythagoras where you are adding the sides together to find the length of the hypotenuse. Let's have a look at what happens when it's the other way round. Okay, so here we go. This time we've been given the length of the hypotenuse in this question, so we've been given 16 and we've been given one of the shorter sides, which is 8. Now you can actually learn another formula here. You can learn, you know, the reverse of the Pythagoras formula for working out a shorter side, or you can just remember that when you are finding a shorter side you're going to subtract rather than add. So you can rearrange the formula. Our original formula is a squared plus b squared equals c squared. And if we want to find out what a or b squared is, we can just take away a or b squared from both sides. So we could have, let's just take away the b squared. We'll have a squared equals c squared minus b squared. Now it is important in this sense when you're doing this that we know which one we're taking away from which, particularly if you're not going to rearrange the formula and you're just going to use a little bit of a trick, which is also fine to do. But I'm going to have to do 16 squared, the length of the hypotenuse, take away the smaller side there, which is 8 squared. If I did it the other way around, I'd obviously get a negative number. If I type that into my calculator now, if I do 8 squared take away 16 squared, I get negative 192, and you can't have a negative length and we can't square root a negative number. So that's not going to work. So you've just got to be careful that you do 16 squared and you take away 8 squared, although that obviously gives you positive 192. So even if you do it the wrong way round, you can actually just get away with getting rid of the negative sign, but we should make sure we're doing it in the correct order here. So we get 192. Now it's the same process again. That is obviously a squared there, because well, the way that we labelled it. Let's imagine that 8 in our case here was b, and this was c. And if we square root 192, let's see what we get. Square root answer, and we get 13.856, and a few more decimals after that. But again, it wants it to 3 significant figures. So I'm just going to save writing too much on the screen here. So if we're rounding this to 3 significant figures, we chop it after the 8. The 1 is the first significant figure, the 3 is the second, the 8 is the third, and our final answer there comes out as 13 point, and the 8 goes up to a 9 in this case because it's a 5 again, and that is again in centimetres, so 13.9 centimetres. So you've just got to remember, when you're doing Pythagoras theorem, you square both the sides, so square, square, and then you plus or minus, and then root your answer. Okay, you plus them or add them together when you're trying to find the longest length, and you minus them or subtract them when you're trying to find the shortest length. So square, square, plus or minus, and then root. And here's a couple of questions for you to have a go at. Okay, so here's 2 questions, both again asking you to round to 3 significant figures, so both of these questions are calculator questions, but pause the video there, have a go, and we'll go over the answer in a sec. Okay, so the first one, and we have got some decimals in this one, so it's a little bit different, but we are trying to find the longest length, look opposite the right angle. So we're going to do 3.2 squared, add it to 1.7 squared, we're going to work that out and square root the answer. So straight into the calculator, 3.2 squared, add 1.7 squared, that equals 13.13. You can write that in if you want, 13.13. And then we're going to do the square root of that, so the square root of 13.13. So square root answer, and I get the answer 3, that's a weird 3, let's rewrite that, 3.6235. And a few more decimals, but again we're going to round it to 3 significant figures, which is after the 2 in this case, and there we are, that is 3.62, and again this was in centimetres, and there's the final answer for that one there. Okay, moving on to the next one. We are trying to find the shorter length. Obviously we've got the 9 here opposite the right angle, so we're going to do 9 squared, and we're going to take away the 6 squared. And 9 squared, take away 6 squared. You might argue that you can do that bit without a calculator, but we get the answer 45, and to square root that we are going to need the calculator for that. So the square root of 45, it's going to be just less than 7 somewhere, let's have a look. So square root answer, and we get 6.708. There we go. And a few more decimals, but again, I only need it to a certain amount of significant figures here. So the third significant figure here is that 0. We've got 6, 7, and then 0, and we've got an 8 after the 0 there, so that's going to round up. So it's 6.71, and again, it's in centimetres. There we are. And there is our final answer. Let's have a look at some slightly different questions then, where it's not just as straightforward as a right angle triangle finding one of the lengths. Okay, so this question says work out the length of BC. Let's just identify that there. So the length BC is this length across here. And it says give your answer to correct to 3 significant figures. Now straight away it doesn't actually stand out that you definitely need to use Pythagoras for this, but we are working out lengths, and Pythagoras is one of the skills we have to work out lengths in different shapes. Obviously only when it comes to right angled triangles, but different shapes. If we can find a right angled triangle somewhere, we can apply Pythagoras to help us work it out. And in this type of question, look, if I chop from the D down to the base, that creates a right angled triangle here on the right, and we have a rectangle on the left. Now because it's a rectangle on the left, we can say that the 2.1 there is the same as the 2.1 down here, and that's in metres, and the 1.9 there is the same as the 1.9 over here. Now that means that we've got enough lengths in this right angled triangle now, we've got the 3.2 and the 1.9 to work out the lengths down the bottom here, which I'll put a little X next to. And then once we've got that, we can combine it with the 2.1. So looking at that right angled triangle we've got the hypotenuse, look opposite our right angle. So we're going to do square, square, and then minus, and then root. So 3.2 squared take away 1.9 squared. We'll work that out and then root the answer. So on the calculator, 3.2 squared, take away 1.9 squared, and that equals 6.63. There we go, 6.63. So square rooting that, so 6.63, the square root of that, and that equals, let's have a look, 2.5748. 2.5748 and a few more decimals. Now again, it says it wants our answer correct to 3 significant figures. Obviously, just make sure you read that. So if we round this to 3 significant figures, we get 2.57. There we go. And this is in meters this time, so 2.57 meters, and I can label that down here, 2.57 meters. Now I can work out the full length of BC there, because we've got the 2.1 and the 2.57, and if we add those together, 2.1 plus 2.57 comes out as 4.67. So let's just write the working out for that down up here. 2.1 add 2.57. I should probably tidy that up with a 0, and that comes out as 7, 6 and 4. So 4.67 meters, and there is our final answer for that question. Let's have a look at one other kind of question similar to this one. Okay, so this question says work out the length of AC and give your answer correct to 3 significant figures. Now if we have a look, just to start off with, if I was to connect A to C, it would form this length right here. And that obviously just starts to throw things up a little bit. So I'm actually going to take a slightly different approach to this to start with, because if you have a look, the right angled triangle that we've created here, we've got the 9, we've not got the hypotenuse, and we've not got BC. So because I've only got one missing length in that triangle, it's pretty useless for me to have a look at it at the moment. So there must be another length we can find first. So if I come back to this and let's have a look. Looking at what we've got at the moment, if I try and find a right angled triangle somewhere, I can do that this time by chopping across. And if we chop across there, we might be able to work out this length down here. Obviously that was the base of the big right angle triangle we've just drawn. Let's have a look if we can do. Now we've got a rectangle on the bottom. We don't know the top and the bottom, but we do know that the 3 over here, which must mean this is 3 over here. And the full length of AB, this length here, it says is 9. So if that part that I've just drawn in is 3, this top bit here must be 6. And that now means that in this right angle triangle, we've got 2 of the missing lengths, and we can work out that dotted line there, which is going to be the same as x down the bottom. And I can do that again using Pythagoras. We've got the hypotenuse there, which is 10. So we can do 10 squared, take away 6 squared, and 10 squared take away 6 squared is 64, I believe. Let's just have a check. That's 100 take away 36, which yes is 64. Okay, so that's quite a nice one, because we can square root that without a calculator. And the square root of 64 is 8 centimetres, there we go. So this length here, and let's do that in a different colour, is now 8 centimetres. That is not a C, that's a backwards C. I think I was going to write 8x there, so 8 centimetres. And that is the same as the x down the bottom, 8 centimetres as well. So now we've got that, and again I've had to do a bit of drawing over the diagram here, but if we get rid of this now, and we have a look at what we've now got the base of that right angled triangle that I drew in initially. And if we connect up A to C, look, and I've not done that very well there, it'd be handy if I could do this with a ruler, but A to C, there we go, has now formed this big right angled triangle. And if I just highlight that, we've got a big right angled triangle there, which we now have 2 of the missing lengths for. We've got the 9 on the side, which was the full length that we had initially, and we've now got the 8 centimetres down the bottom there, which we can now use to work out the length of that hypotenuse, which is the length AC. So to work that out, just a nice bit of Pythagoras here. Look, we're trying to find the longest side. So we've got 9 squared plus 8 squared, and 9 squared plus 8 squared, and this is a calculator question because it says 3 significant figures. It comes out as 145, and we need to square root 145, and the square root of 145 is 12.0415. There we go, 12.0415 and a few more decimals. Now to finish this question off, we've just got to round it. 3 significant figures, so 1, 2 and 0 is my third, and that 4 isn't enough to round it up, so it goes to 12 point, and here's a good little tip here, look, we have to keep the 0 in there. That is our third significant figure. So although we wouldn't normally write 12 as 12.0, it's asked for 3 significant figures, so we do have to keep the 0 in there, and that is centimetres, and there we go, and there's our final answer, 12 centimetres. Okay, so it's just thinking about a different way of using Pythagoras. That one there was a little bit trickier because we had to go in 2 steps and work out a different line before looking at AC, but there's just something to be thinking about. And here's a little question for you to have a go at. Okay, so have a read of this question. It says a part of the field is in the shape of a trapezium and a farmer wants to put a fence all the way around the outside, so we're looking at the perimeter of the shape. Now there's obviously one length missing there to work out the perimeter, so have a go at working out that missing length and then see if you can work out the full perimeter of this field here. So pause the video there, have a go, and we'll go over the answer in a sec. Okay, so for the answer for this one then. Now the way to chop this to get our little right angled triangle is to chop it across the top, and that makes a little right angled triangle here sitting on top. Now the length on the left is 11, so this bit here is also 11, which means that the length just above there must be 7 centimetres. So we've got one of the lengths of the right angled triangle there. Again, we've got another length down the bottom. We've got 10 metres down the bottom here. I've just realised I put centimetres, that should have been metres. Let's change that. Make sure you read the units. There we go, so that's 7 metres. And obviously the 10 metres down the bottom corresponds to the little 10 metres at the top just there. So there is the 2 lengths of this right angled triangle. Now we can use Pythagoras, look, because we've just got to work out the length opposite this right angle. So we can do Pythagoras straight away on that one. So 7 squared, add 10 squared, and that equals 149. Now 100 square root of 149 is, let's have a look, 12.206. So let's just write that working out down. The square root of 149 equals 12.206. There we go. And a few more decimals there. Right, now that means that that's that length, so 12.206. And now we just have to work out the full length of the perimeter. Now it doesn't actually say in this question what to round it to, but we're going to round it to I'm just going to round it to a certain degree of accuracy here, which would make sense. Obviously, once it comes to metres of fences, we're not really going to be too concerned about, you know, the 0.5 millimetres worth of fence. Okay, so it would normally say in a question what to round it to, but we're not going to worry too much about it in this question. So it says 18 over here, 10 down here, 11 there, and we've got the 12.206 that we've just got. To be fair, it actually was a 5 after the 6, so if anything, we should round it to 207. But I'm actually gonna just round it to 12.21. There we go. As an amount of meters. There we go. So there we go. Add these up. We've got 11 plus 18 plus 10 plus this 12.21. There we go. And if we add all of those up, let's have a look what we get. 11 plus 18 plus 10 plus 12.21. And that all adds up to 51.21 meters. There we go. And there's our final answer. Obviously, as I said though, normally a question would ask us how to round it, but in this particular question we're just having a little bit of a think of you about using Pythagoras, not too much about the rounding there. But there is a little idea of another way that Pythagoras could be involved, looking at the perimeter of something as well as just finding out one of the missing lengths. Right, I've got one more thing for us to have a look at before we finish. Okay, so this question here, there's 2 right-angled triangles, and it says work out the value of x, and if we just highlight that, x is down here, and again, giving your answer to 2 decimal places. Now, to start with, we can't find any of the lengths on this triangle down the bottom here, and if I just highlight that triangle, this one here, because we've only got the one missing length, we've just got the 4 there. So again, we must be able to get one of these lengths from the triangle above. And if you have a look at the triangle above, we can do that. We've got the hypotenuse opposite there, and we've got one of the shorter lengths as 5. So we've got the hypotenuse, so we can do 10 squared, take away 5 squared, and we can square root the answer. 100 take away 25 is 75. Now if we do the square root of 75, let's have a look what we get there. That is 8.66 and a few more decimals. I'm going to leave that as 8.66. Let's label that down here. So 8.66. Now, as I'm going to be using that number there, I'm going to leave that on my calculator because I want to make sure that I don't get any rounding errors here. But let's have a look at the second step. Now, leaving that number on my calculator, let's identify what we're looking for. This time we're looking for the hypotenuse, look opposite that right angle. We've got the 4, we've got the 8.66. So we just need to do 8.66, that number squared, which I'm going to do as my answer squared. So I'll do 8.66 with all those decimals in my calculator squared. I'm going to add it to 4 squared and see what I get. So answer squared plus 4 squared, and that equals 91. There we go, and that equals 91. So to finish this off, look, square root of 91, and we'll write down what that equals there. So the square root of my answer is 9.539. 9.539. There's a few more decimals there, but again, it only said in the question to 2 decimal places, so I'll write it down to at least 3. So we've got 9.539 with a few more decimals as our answer, and 2 decimal places, we'll chop that after the 3, and that's going to equal 9.54, because that 9 rounds it up, and again that is in centimetres. Need to make sure I read my units this time. There we go, and there is our final answer for this question. Now I've got one of these for you to have a go at, so here it is. So pause the video there, have a go at this question, and we'll go over the answers in a sec. Okay, so calculate the length of DC, and DC, just to highlight that, is down here, one of the shorter lengths of that right angled triangle. Now if we start labelling this up, on the first right angled triangle on the top there, we can work out the hypotenuse here. So if we do our Pythagoras for that, we've got 3.6 squared, add 9.8 squared, and let's see what we get for that. 3.6 squared plus 9.8 squared equals 109. And we're going to square root 109. And the square root of 109 is 10.44. And a few more decimals after that. And again, I'm going to take the same approach here. I'm going to leave that on my calculator for the moment as the full decimal. Having a look at the next one, we've got another right angled triangle here. This time we've got the hypotenuse, and we're trying to work out this missing length down here, so one of the shorter sides. So I need to do the hypotenuse, 10.44, the one on my calculator squared, take away 8.4 squared, and see what I get for that. So answer squared, take away 8.4 squared, and that equals 38.44. So 38.44. And again, to finish this off, I just need to square root that. So the square root of 38.44, square root answer, and I get 6.2. There we go. And that actually comes out as an answer to 1 decimal place, so 6.2 centimetres. Now I would imagine that what would have happened is, if at this point we had have rounded our answer and not used the full one on the calculator screen, our final answer here would have come to more than 1 decimal place, and hopefully it still would have rounded to 6.2 to 1 decimal place there, although there would be a level of accuracy that you would be allowed on a question like this if you did round that to a certain amount. Okay, so 6.2 is our final answer there. And that is the end of Pythagoras. Okay, so obviously moving on from this topic, we're going to start to have a look at SOHCAHTOA and having a look at working out lengths on right angled triangles when we've got some angles involved. But Pythagoras there is for right angled triangles when there are no angles involved in the question. Okay, so that's the end of the video. If you found that helpful, if it was useful, please like, please comment, please subscribe, and I'll see you for the next one.